Hey, good afternoon, everybody, or good morning, West Coast. I'm very excited about a number of things. I'm really excited about being able to talk a little bit more about the safety basics because I think it's a point of confusion and it's an issue that some of our customers struggle with. And then I'm also excited to announce that we are now Vega Light Control Systems. We're proud to launch our new name, Vega Light Control Systems, as part of our ongoing brand evolution. MATEC has grown and progressed over the last 20 years, and I'm really proud of what we've accomplished. And our vision and product offerings have disrupted the market. A new name and brand to support our continued growth better reflects who we are today and symbolizes our dynamic future. We've got some really neat things planned. So why Vega, you ask? Because Vega is the brightest star in the constellation of Lyra and is the baseline for calibrating the photometric brightness scale. Because of our commitment to lighting standards, our devotion to being the benchmark in performance and light control, not to mention our desire to stand out, Vega perfectly represents our brand. So what's next? In the upcoming months, expect to see our new name and logo on all marketing literature and on our online presence. For the next few months, our website will remain the same, but you can now find it at www.vegalightcontrol.com. We can still be reached at the MATEC email addresses, but are starting the transition to Vega Light Control. So, hey, it's an exciting time for us. We've got some really neat things going on, and we've also got some really exciting things planned as far as the IES show is concerned. But let me focus on something not specific to Vega lighting, but let me focus on a really important topic that I think, like I said, a lot of our customers struggle with, and it's something that I hope that we can add some clarity to try to simplify and to make application of LED technology something that people can do with much more confidence. So I want to talk specifically about the safety basics and really how to design and how to convert with confidence. Creating a lighting installation that enhances safety requires a plan. I've never seen it happen by accident. Safe lighting can be as ambiguous as good lighting. If you ask 5 people, you'll get 7 opinions. It's one of these things that people have a hard time defining. The evolution of lighting technology has created confusion. I heard somebody say the other day that everything has changed in lighting, which actually is not true. Most of the things have remained the same as far as the standards have evolved, but not significantly. How your eye adapts to an environment or how your eye operates has not changed. What has changed is the light source, and so we need to be better educated on that light source and how to properly apply it. Bright and shiny and lowest price seldom result in the selection of the right product. I love a deal as much as the next guy. However, it's not my number one priority. I really like to look at cost of ownership and long-term operating costs as a priority. And if I can also get a fantastic price, that's great. But brightest and cheapest seldom produces a good result. The key to safe lighting is understanding what to look out for and well-established lighting standards. Simple tools and strategies exist to answer key questions before the installation. We often talk about we like nice, boring, predictable lighting projects, and that's what we strive for each and every time. And there's some really great predictive tools that you can use up front, and there's some really simple ways to apply them. Following simple, proven guidelines and applying the right tools will produce a consistent and superior result. So let's talk a little bit about the evolution of the technology and how that's created some confusion. And as you know, or as you probably know about us, we are heavily focused on street and area lighting, specifically in decorative fixtures. So you're going to see a lot of references to decorative fixtures. And if we decided to expand that out to, for instance, parking lot, Cobra heads, and all the other, variants of outdoor and area lighting products, we could turn this into a full day seminar. So I'm just going to focus on decorative because I think we got some great examples, great photographs that'll help illustrate some of the points. So what's happened in the industry is non-lighting people have flooded the marketplace. LEDs have made it easy for anyone who can apply an LED to a circuit board to all of a sudden get into the lighting industry. So a good understanding of lighting science and standards is hard to find. We kind of joke around internally, hurts my eyes is not a standard of excellence in lighting performance. So bright that I can't see, that one gave me spots. Those are not standards of excellence in light performance. There's also the brighter is better slippery slope. And that's not true in street and area lighting in most cases. what you find is that you have to be cognizant of things like uniformity and ensuring that you don't have too great a range of light levels. Because as you transition from, for instance, a brightly lit area to a dimly lit area, you can have temporary blindness. Just as one example. So brighter is not always better, and it's something we have to be careful with. Design Lights Consortium is not a measure of performance to lighting standards. It's a utility rebate program that's based on lumens per watt. And although lumens per watt is a great measure of how efficiently an LED will convert energy to light, it is not a measure as to whether, in fact, that light source is actually going to produce the results we're looking for. So there are some other tools that we can use that do a much better job. Many solutions are driven more by marketing than by good lighting design principles, standards, and science. So we have to remember, again, that because we've had so many people from outside the lighting industry get into the lighting industry, we see a lot of things which are being promoted that really have little to do with either the performance of a product, its ability to meet standards, or the reliability of that product. Lighting standards are still relevant because they are based on how our eyes operate, which has changed little in thousands of years. It's all about the human eye. It's all about how well the human eye adapts to an environment. It's how we perceive, whether it's motion, periphery movement, color, how our eye transitions between three modes of operation. I mean, all those things are built into lighting standards. So what's nice is we don't have to become an expert on how the eye operates. We have to become proficient in how to apply the standards based on that. I want to give you some examples, and in this webinar, you're going to see some pretty cool pictures. We've had a lot of fun over the years, and this is a project that when I worked on when I was at Osram, Slovenia. So I was there for a number of years, and they had a lot of success there, had a great experience. So this is Bridgeport, Connecticut. So we approached Bridgeport, Connecticut about a retrofit project, and we said, well, you probably want to do a lighting layout, want to do a limited installation, don't intermix high-pressure sodium and LED because you want to be able to have a clear, congruent space where you can take lighting levels. And they pretty much disregarded all of our recommendations, and here you see the result. So what they did is they turned this into we call it a beauty contest. Which one's prettier? Is it in fact adequate light? Are we happy with the color and light level? And fortunately, Bridgeport was successful, but it was probably more by accident than by plan. Probably has more to do with the fact that I think looks like their pole spacing is about a 10-foot pole spacing, and which really is actually closer to about 50 feet. So the evaluation process for a lot of people is it's a lighting beauty contest. Most customers evaluate lighting based on which one is the best looking and which one is the lowest cost. Unfortunately, that seldom works. You either get too much light, not enough light, too much glare, the wrong distribution, short life, et cetera, et cetera, et cetera. So this is really about going beyond that beauty contest and being not only successful in the product selection, but selecting a product which is going to create a safe lighting environment. Let's talk about some fundamentals with regards to decorative street lighting. I think this is a good example. This is just a diagram which shows your typical decorative fixture. You may have a 100-watt high-pressure sodium, 150-watt high-pressure sodium. You're going to have some light which is horizontal, some that goes up. You can see that the critical area is 70 degrees from nadir, kind of a large cone. And that's the area where that light matters. That light actually defines our distribution, has a lot to do with our vertical luminance, and is critically important in achieving lighting standards. Above that is, for the most part, wasted light. What's also interesting, you'll notice that from the 0 degree position down about 20 degrees, or your high angle light, from nadir would be in your 70 to 90 degree range. That's where most of your glare comes from. And a good analogy would be is that if you had somebody at distance holding a flashlight and they shine that flashlight in your eyes, the first result would be is that your eyes are going to constrict as a result. You're going to lose a lot of your periphery vision, a lot of your detail, and you're not going to have the vision or the visual acuity that you had prior. If they take that same flashlight and point it to the ground, now that's actually going to improve your vision. So it's a good example where if you throw a lot of light horizontally, you're actually going to typically restrict vision, although that is the light that makes a light source appear bright. And that's where the confusion exists when people go through, as I mentioned, as they go through the beauty contest. So spec-compliant light sources really has to do with light control, reducing the waste and the glare, reducing the uplight. Light at or below 70 degrees is really the critical point. We've seen some in lower pole mountings where maybe up to 75 degrees is still valuable, but you start getting above that and you're producing waste. So you want to minimize your uplight and glare. Your uniform illumination of the ground is important. It's one of the standards. Dark skies friendly or compliance. It's something that I think we're going to continue to get more and more pressure to reduce uplight and to be compliant. And then, of course, the issue of rebate approval with DLC, for example. So we want to meet or exceed the performance of an existing light source or meet the IES RP8, in this case, standards. And we'll talk a little bit more about that standard. So let's take a reality check. Oftentimes we get excited about lumens per watt and lumen output. Let's look at, probably many of us have dealt with 150 watt high pressure sodium. And you can see in this chart, 150 watt high pressure sodium mean lumen output is just over 14,000 lumens. So if we had a non-directional light source that we wanted to use to replace the high pressure sodium, if we wanted to produce the same light level on the ground, we would have to use a 14,000 lumen LED light source, unless we had a directional light source. And I'm going to talk more about that. What's also interesting, I've seen this before and kind of get a kick out of this. I had somebody the other day tell me that they could replace a 400 watt high pressure sodium with an 80 watt LED. And I just responded with, not on its best day. 400 watt high pressure sodium mean lumen output is 42,740 lumens. So I don't know too many LED light sources that have that kind of efficacy to produce adequate lumen output to replace a light source like that. Here's an example of one technology, and I want to highlight this because it's really about understanding these concepts, because this is all going to build into safe lighting. So I want to just highlight this particular technology because it's rather interesting, although there are other technologies. But you want to apply some of the same principles when you're screening technologies or selecting technologies for an application. So in this particular case, this technology represents a low price. It's easy to install. It's bright in appearance. Usually it's a reduced quality driver for a lot of reasons. Reduced surge suppression, usually it's closer to around 10 kV built in. And reduced light performance because it produces mostly horizontal light. In general, this product segment is known for poor reliability and poor light performance, but it looks good from the ground, although it fails most important criteria. So it's interesting to understand this technology and how it compares to some of the other light sources. If you think back to that decorative acorn diagram that I showed you, let's use this as an example. We have a 16,000 lumen non-directional light source. We have, that's the conventional. We have an 8,000 lumen non-directional light source, the LED, and then we have an 8,000 lumen directional light source. The fact is that the 8,000 lumen non-directional LED light source is going to be half the lumen output necessary to replace, photometrically replace that HID light source, because there's no directional light control. In fact, unfortunately, as I mentioned before, that high angle light or that horizontal light is what these units produce the most of. And as a result, they have a very high glare or a very high appearance of brightness. If you have a directional system that's engineered to direct the light where it belongs, then you can get away with 8,000 lumens to replace a 16,000 lumen non-directional HID light source. So I hope that makes sense. I hope the point is clear in that directional versus non-directional, it makes a huge difference. It's not so much about the lumens per watt. It's really about how many lumens are within the range of that's important for producing a photometric distribution. Here's a great photograph, and I'll give you a little bit of background on this. I was traveling in Pennsylvania. I had a drone with me. I was actually traveling out for a Dominion project, but had a drone with me, and I stayed at one of these hotels and walked into the restaurant. So this is an aerial view of the restaurant in the center, and then there's a hotel on the left and a hotel on the right. Walked into the restaurant just about sunset, walked out when it had turned dark, and I noticed just the most interesting situation. So the situation was that there were bright lights all around the parking lot, and yet the parking lot was pitch dark. And I kind of liken it to standing in water and not getting wet. It was just counterintuitive. So having the drone put the drone up in the air and took this photograph. So what you see in the center is that the restaurant went with a screw-in product, which of course is going to produce a lot of horizontal light, but is not going to direct very much light to the ground. The hotel on the left engineered new fixture LED solution, and you can see great uniformity, great visual acuity. They really did a nice job, and they, by the way, have a shared drive, kind of a snaking drive off to the left of the restaurant. So you can really see the contrast with the two being right next door. Off to the right is your more traditional scenario where they have 400-watt metal halide shoeboxes, not very well maintained. They've probably gone through quite a bit of lumen depreciation, but still you can see the visual acuity in that environment is far superior to the visual acuity in the restaurant parking lot. So it's amazing. When you look at it from the ground, you see the high angle light. Your perception is it's bright, and yet, unfortunately, it's really a almost dangerous environment. It's so poorly lit. You can see so little out in that parking lot that it really raises questions about safety and security. So here's kind of a little bit of a reality check. Problem lighting projects do not happen by accident. Someone had to violate good lighting design principles to get there. And I found that. I've been called in on a few, I'll call them autopsy lighting projects, where it really started with a beauty contest and just went downhill rapidly from there. Watts and lumens do not determine if a light source meets the requirements of an application. Neither is a good measure of good photometric performance. Here's a test installation. This is kind of a good example of a head-to-head with LEDs. On the right is a 55-watt LED, and on the left is a 60-watt LED. From the ground, they both look bright. How do you select the difference? Which one's going to be better? Why is it that so many of these projects, the only way to figure out whether the product's going to perform or not is either you do test installs or you do retrofits and conversions and kind of cross your fingers, hold your breath. This is a good example of things gone right, things gone wrong. The next one is an image of an application that many of you are probably familiar with. This is the virtual reality tour site, the Ada Bible Church, and this is from a little different perspective. This is, you can see the intensity, the light intensity, almost the glare of the LED screw-in bulb versus the S7 shoebox retrofits. Now, interesting thing about this is that they all had similar brightness or glare, yet the lumen output of the S7 is close to 3 times the LED screw-in bulb. This really speaks to the power of light control. When you have good light control, you have a well-engineered light source, you can reduce your glare and you can produce a well-lit environment. And of course, the next picture speaks volumes. I think, I probably don't need to add too much to this, but on the left are your screw-in products, and on your right is your S7 shoebox retrofit. And this is not about Vega products. This is really about understanding the difference and also understanding how to discern what product is going to produce what kind of results for you. Let's talk about some safe lighting components. So roadway lighting, basics of safety. Safe lighting has several major elements: motorist safety, pedestrian safety, protection of wildlife and habitat, which, by the way, I'm not going to spend a lot of time on that one today, but it's something that we can certainly talk about, or we can even have a follow-on discussion on. Protection of property, and then minimizing potential liability. Human eye adaptation must be considered in safe lighting systems. So, in other words, our eyes all adapt to the environment. And I gave an example before where you go from a brightly lit environment to a low light environment. Your eyes need to adapt to that transition. And you're going to lose, temporarily, you're going to lose your visual acuity until your eyes then readjust. So standards are really about restricting that or maintaining uniformity to ensure that you don't have those type of extreme transitions, which are then going to produce a temporary blindness condition. Excuse me. So when we look at safe roadway lighting, it really is a technical challenge, but I'm going to show you in a moment some tools that we can use to execute a safe roadway application. So the objective is to improve traffic safety and law enforcement efforts by enabling people to see comfortably and identify objects in the roadway quickly and accurately during darkness and under a wide variety of weather conditions. And that means we're going to have to consider things like horizontal luminance, vertical illuminance, minimize direct and reflected glare, minimize extreme brightness differences like I talked about, that uniformity, minimize light pollution, light trespass, and uplight. Nothing like putting light in somebody's bedroom. You're pretty quick to find out how much they don't like it. Peripheral detection, minimizing shadows, also supporting some of the energy conservation and maintenance objectives. That really gets into your return on investment and also into your long-term operating cost savings. And then circadian sleep rhythms, which are circadian sleep rhythms really play into the AMA report. And we're not going to go into a lot of detail on the AMA report, although I do reference it in this webinar. But suffice it to say that there is some evidence and quite a bit of research pointing to that we probably don't want to go to a high blue content or very high color temperature light sources, but instead want to get closer to 3,000 K, 3,000 to 4,000 K in street lighting and outdoor lighting environments. And again, we can talk more about that. Safety and security elements. You've got the identification of hazards or obstructions, accidents avoidance, and in fact, interestingly enough, one of the things that is built right into standards and specifications is something called levels of pedestrian conflict, and that's pedestrian conflict with motorized vehicles. So it's something that's considered. From a security standpoint, creating the perception of safety or comfort, reducing the opportunity for a person to hide. I think we've all seen videos and images of in a high glare environment, how you can hide someone in the shadows. Create a scene where movement can be detected. Create a fear of detection, identification, or apprehension by potential criminals. Interestingly, when I was out one evening on that Ada Bible Church site, I stood out in the parking lot, was just taking a few photographs, and all of a sudden the timer shut all of the lights off. And I was standing in pitch darkness. And it was interesting how all of a sudden I become attuned to every sound and really have this uneasy feeling of, I need to turn some lights on. I need to get in my vehicle because I have no idea. I can't see anymore what's out there. So having a well-lit environment really goes a long way for supporting that perception of comfort or perception of safety. You want to avoid situations that hamper seeing or causing visual confusion. You want to provide adequate illuminance, vertical and horizontal. You want to look at your ratios, avoiding glare. Again, I've talked a lot about glare, and I don't know if it's something I can talk enough about because it's one of the things that we see time and time again is people selecting high glare light sources and really undermining the value of the installation. You want to minimize the harsh shadows and, of course, the contrast and color recognition. In safe lighting, glare and vision is critical. Is brighter better, and is more a good thing or a bad thing? And I think suffice it to say that brighter is not necessarily better. In fact, in a lot of cases, brighter can be worse. It's something you really have to look at. And according to the 2012 report from the AMA, glare from nighttime lighting can create hazards ranging from discomfort to visual disability. The IDA also reports outdoor lighting is intended to enhance safety and security at night, but too much lighting can actually have the opposite effect. Visibility should always be the goal. Glare from bright, unshielded lights actually decreases safety because it shines in our eyes and constricts our pupils. This cannot be blinding. This cannot only be blinding, it also makes it more difficult for our eyes to adjust to low light conditions. The perception of safety is achieved in a well-lit, low-glare environment where pedestrian conflict with motorized vehicles is reduced, and where vertical illumination supports easy facial recognition, identification, and recognition. In short, these are the considerations that go into the applicable lighting standards. So let's talk about the keys to success in a safe lighting environment or application. Number one, lighting standards. And I'm going to talk a little bit about that. IES has been involved in a couple different approaches, and IES is also joined with the International Dark Skies Association. International Dark Skies Association to release the model lighting ordinance, and that has been quite successful in helping people as far as providing munis, for example, with a great format or tool for quickly deploying a robust standard. Proven tools are available that predict what the environment will look like before installing the first lights. There's some great tools, some great photometric tools that are really easy to apply. Directed and controlled light sources are required to achieve lighting standards. Lumens per watt is not the key. And I've seen it time and time again that someone hits a lumen per watt target, but they've got a light source that simply cannot achieve lighting standards. It's because it's not about the amount of light, it's what you do with the light. The reliability and the light control is paramount. Small test installs help validate analysis results, and create consensus in the community. So you can do a small test install, give everybody a chance to get familiar with the product, how it's going to look. And that's a great way also to create consensus. So no one person has to make the decision on a large install by themselves. They can create that consensus so everyone's in support of making that conversion. And I want to promise you, once you do your test install, that's where you have 5 people that give you 7 different opinions. Understanding the numbers, performance lighting standards. I think there's a lot of protection in lighting standards, and we'll talk about that. The payback, return on investment, cost of ownership, including reliability, and finally, converting with confidence. So let's take the adventure out of lighting. I'm a big fan of nice, boring, predictable lighting projects. I like people to be able to develop hobbies, go off and do what they like to do after hours instead of, responding to a never-ending stream of phone calls, people complaining about they're not happy with this light source, or we've got issues, or we've got failures, or you name it. So let's talk about lighting standards. The Illuminating Engineering Society, which I'm a member of, has IES standards. They've got their published recommended practices. IES recommended practices are the recognized legal standard. It's really ANSI recognized for street lighting across the U.S. and most of Canada. Roadway standards, which is RP8 or recommended practice 8, it applies to most outdoor street lighting applications. Another example is parking lot standards, RP20, and on and on and on. There's actually volumes and volumes of these recommended practices. And what's great about this is these standards are based on the operation of the eye, and they apply to your specific environment. So it takes the mystery out of this. Customers can be exposed to some legal liability based on lighting standards compliance. We saw that when I was at Sylvania, where someone would be called in, a lighting specialist would be called in to be a witness at a lawsuit, and our people would have to go out, take light levels, and try to determine whether, in fact, that in that, let's say, city block where the crime took place, whether or not they met IES RP8. So it's an important standard in that regard. There is not a law that requires lighting standards compliance, but it is a good, prudent practice to protect yourself from legal liability. It's an excellent standard. Compliance is fairly easy to plan for and verify, and compliance's primary focus is uniformity. Minimum light level and uniformity is key, and we'll talk a little bit about that. Like I said before, brighter is not necessarily better. A bright appearance may not be enough. So it really has to do with standards compliance versus our visual evaluation of a light source. Another lighting standard, which I think is a great tool, and I would encourage really any, for instance, Muni to look at, would be the Model Lighting Ordinance. It was a collaborative effort between the International Dark Sky Society and the Illuminating Engineering Society, about a 7-year effort. It's a template for easy application and adaption for communities. It's a very good basis for community lighting standards. So if I was in charge of the lighting system in a Muni, this is something that I would seriously consider putting in place. I think it's a great tool. It's a very simple way. You don't have to become a lighting engineer or lighting specialist to understand it. The lighting community understands it. Lighting manufacturers understand it. And it's a great way to protect yourself when you're deploying a system, writing a bid, you name it. It divides the area into zones with specific guidelines, and you can actually download that format or that template on www.darksky.org. I want to take and use as an example one particular installation, which I think is going to be interesting to everyone, and I want to kind of guide you through what we did. And again, this is not about our product. This is really about following the process, because the end result was a safe lighting system where lighting system that the customer was extremely happy with and demonstrated all the attributes of a safe lighting system. So on the left, you can see the small daytime photograph, and then of course on the left, who wouldn't miss the high pressure sodium? That light color, isn't that something? And then on the right, you have the end result with LED. Interesting to look at the sidewalks. I think they're a great indicator of uniformity and just how well these lights are projecting light out. Here is an LED, a short distribution LED in the same installation. And I wanted to highlight this because this goes back to the confusion with the technology. All these lights look very bright. And I showed you before corn cobs. Corn cobs do a great job of throwing the light horizontally, but don't do a very good job putting it on the ground. There's also families of products which do not do a very good job of throwing the light out. They're more downlight type light sources. They just don't have the engineered optic. They end up producing a very short distribution. And as a result, you get this kind of lack of uniformity like what you see there. The customer referred to that as the snake down the street. You can see the snake, the dark snake down that rolls down the street. You also have a hard time viewing the sidewalks all the way down the street. The next one, of course, is the finished product. So after we made the conversion, you can see the uniformity. You can see the sidewalk all the way down the street. The customer was ecstatic. Here's some before pictures on the top. Then you have the short distribution setup in the middle, and then you have the finished product down below. So it's a pretty dramatic transformation. Now, here's one of the tools that we use for these type of applications, and I'm going to zoom in on some of this here in just a moment. But a lighting layout is not difficult to have done. It's really something that there are many sources for this type of technical support, and we can also provide that type of technical support as well. But a lighting layout is key in understanding how a light source is going to perform before you actually install it. It's something that I use. I use it religiously, and it's something that I encourage other people to use as well. I want to zoom in so you can see some of the details on this particular install. So on the top, you can see the outline of the kind of the photometric plot of the footprint, lighting footprint of each luminaire across the street. Then down below, you see the actual calculation results. So you can see the luminance and foot candles, 0.7 average, your max to min ratios, average to min, and then you can compare that to the IES RP8 standards and determine whether, in fact, you are compliant. Which, by the way, in this application, they were not compliant, and that had to do with existing pole locations. And something that I want to talk about just briefly. A lot of communities say, oh, hold on a second, do I need to tear up my poles and respace my poles? No. The direction from the IES is, first and foremost, love to have the customer achieve IES RP8. But if they cannot achieve IES RP8 due to constraints, then you want to meet or exceed the performance of the existing system. And I'm saying an existing well-maintained system, not a severely lumen depreciated, not maintained system. And if anybody has questions on that, let me know. But that is the standard or the approach that IES recommends. So back to the project. So here we have 100 watt high pressure sodium, and below what I've done is I've highlighted the analysis results. And what's kind of interesting here is that the analysis results pretty closely reflect what we saw out on the street, except we had one high pressure sodium lamp that was failing. So you do see a little irregularity, or you see a pretty big dark spot by the intersection. But outside of that, you have a very close representation of the actual in the analysis results. When you look at the short distribution configuration, you can see the analysis again does a good job of identifying where the dark spots are going to be. So we saw a very strong correlation. What's great about this whole project is that there were no surprises, and I think that's one of the most important things that the analysis tools can provide you is they can take away all of the mystery. They can take away the beauty contest. They can take away, hey, this one looks brighter, this one looks better. We talked a lot about glare, but one of the things I didn't talk a lot about, and I really don't want to get into SCO topics in depth, but your eye is more sensitive to high color temperature light in a low light environment. So as a result, it's pretty easy. If I put two light sources next to each other in a street lighting environment, I have one a warmer color temperature and the other one a higher, whiter color temperature. People will select the higher color temperature time and time again as a brighter light source, even though the two may have exactly the same lumen output. So it's something you just have to be careful of. It's one of the many confusing ways that people can get to the perception that we've got an acceptable light source. But when it really comes down to it, it's the performance in the environment that matters. It's what you see in the layout analysis and how that correlates back to real-world application. So successful lighting conversions, really, they're simple when they're done right. What I like to look at is define the application and the conditions. You know, what's we do in a parking lot, we do in a street, what are we doing? Identify the published lighting standards that apply. And you can, if you're not proficient in it, you can certainly get help from lighting specialists. We're out there. And of course, we can help you. Conduct a lighting layout to confirm compliance prior to deploying the product. Like I said, I like nice, boring, predictable lighting projects, and that is a great way to get there. And it's a great way to get to a safe lighting application. Evaluate your priorities based on the numbers. Let the numbers guide you to the right product selection. And that's numbers, not only the financial numbers, but you also have to look realistically in things like, for example, surge protection. If we're looking at a light source and the first light source has 5 kV of suppression, another light source has 25 kV or 36 kV or what have you of suppression, it's logical to think that all other factors being the same, that the higher kV of suppression, the higher level of suppression is going to provide you with a longer life and better reliability. And of course, there's a lot more details into that. And again, we can help you with interpreting or being able to compare one light source versus another. There's also the thermal testing, the in situ testing, what's the actual rated life based on TM21. But those are all details that we can help you with. I encourage people always to install a small quantity. It's a great opportunity for feedback as well as some collaboration or, creating some consensus in the community. I encourage everyone, don't take shortcuts. I had a customer, in fact, just early this morning. We had a conference call, and they wanted to convert to LED, and somebody said, hey, do we need a new photocell? Absolutely. Don't put a short life photocell on a long life LED. Make sure that you're also getting a long life photocell. And then enjoy your successful installation. Develop a new hobby. Get a promotion. Do something with the spare time where you're not spending firefighting an installation that was done poorly in the first place. Standard compliance is a peace of mind and reduced legal risk. Who wouldn't like to standards? So, conclusion, studies do not consistently agree on a correlation between light levels and safety. They actually argue back and forth. In some environments, higher light levels are good. Other environments, higher light levels are bad. But that's the beauty of standards. You can take the mystery and the argument and the opinions out of it if you just work the standards. Studies do agree on the perception of safety and how issues like light level and glare play into it. Safe lighting covers issues of the perception of safety, reduce vehicle and pedestrian conflict, and reduce potential liability. Lighting standards were designed to create a well-lit environment based on how the human eye operates or adapts in an effort to improve safety. And light source selection means looking beyond DLC and looking beyond light lumens per watt. Efficacy and being able to generate an enormous amount of lumens is great, but we also need to understand what we're doing with it. And if it's horizontal light, it actually can be quite bad because it's going to produce a high glare light source. So light control and reliability are paramount. Complying to standards deals with important issues like pedestrian conflict, facial recognition, and protects decision makers from the brighter is better slippery slope or the brighter competition. Hey, my neighbor's light's brighter than mine. I want a brighter light. Well, if you work to standards, you can take away a lot of that. Following a simple process will help produce consistent results in public lighting spaces. So that covers the material. What questions do we have?
We have a question it says, how about the CCT?
The correlated color temperature. So is the question, what is the right CCT, or is the question, is there any more detail about CCT? You want me to just find it?
Saeed, do you want to weigh in? I have unmuted you. Did you want to ask? He says, what is the correct CCT?
What is the correct CCT? So if you go with the AMA and a lot of communities, they're trying to push towards warmer color temperature, and dark skies compliance is also requiring 3000 K CCT or less. If it was my system, I would seriously consider 4000 K on roadway, 3000 K in residential, because I like the higher color temperature because of the higher visual acuity. However, if I was forced to standardize on one color temperature, I would look seriously at 3000 K CCT. And we see that, like, for instance, our largest project is we have the city of Chicago, and which is just a massive project. And the city of Chicago utilizes 3000 K CCT across the board, both in the Cobra heads as well as the decorative fixtures, even though very early on they started with 4000 K. So I hope that answers the question. Other questions? You guys are going easy on me.
Ben Woodhouse says, how does the spectral power distribution profile play in a lumens to lumens comparison between different light source types? And I'm going to unmute Ben, just in case he does want to comment.
Okay. Can you repeat that question, please?
Yep. How does the spectral power distribution profile play in a lumens to lumens comparison between different light source types? Feel free to weigh in, Ben.
Yeah, spectral power distribution is typically not correlated to a lumen per se. I mean, there's not a ratio necessarily, and you're really getting into CCT. Your spectral power distribution, the distribution across the full spectrum, is really going to drive your color rendering and to a degree your CCT. So I would say I would probably correlate it back to color rendering, and I would probably let CRI drive the metric versus trying to interpret the spectral power distribution. Although if I'm trying to avoid high blue content, then power spectral distribution is valuable input. But you only see that kind of analysis in your most extremely technical customers. Most people don't even understand power spectral distribution. So in most cases, I'm not going to use it. Most cases, I'm going to use CRI, unless we have some need to actually go into spectrum. And we've done that, for instance, we have a turkey light project where we have to be very careful about spectral distribution and really in the certain development cycles of the turkeys. This is for Genio turkey farms. So in that case, we do use it, and we use it rather intensively, but that's a unique application and specifically how turkeys respond to those spectrums. Does that answer the question?
Microphone?
Yep.
Yes. Hi, Ben.
Okay, great. Hi, this is Ben. I was the one that asked that question. So I guess I was thinking in terms of when you're, for example, the retrofit corncob LED products, if you're comparing them kind of apples to apples between the HID equivalent that the manufacturer recommends it can replace, although the total lumen output comparison may not be equivalent, can you somehow, and maybe this goes back to your CRI comment, can CRI make up the difference in the sense that since your eyes are more sensitive to the broader spectrum of the LED light, does that make up for the lack of lumens that come from the LED light source?
All right. So what we're doing is we're really factoring in really CCT or correlated color temperature and a high color temperature light. Like, let's say, for instance, we were looking at a corncob product at 4000 K at converting from a 2200 K high pressure sodium product. So it's really what you're getting into is that topic of scotopics. And there are some limited allowances within the ISRP8 for consideration of color temperature in application. But it's very limited, and it's very limited to low speed environment. So I would again go back to kind of default back to, I think going back to the standards, I think are a great way to evaluate products. And I think it's also a great way, if I was looking at, I tend to be pretty non-denominational even about products. I'm critics of our products. I'm critics of other people's products. I want it done right. I want it done right the first time. And so I'll use the same tools on our products that we would use on anybody else's products. And the same holds true in this particular case. I would still evaluate light performance based on IES files, photometric layout, and make sure that I'm evaluating performance against standard.
Okay.
And by the way, Ben, I'd be happy to take the discussion offline if you want to go into more detail. And if I can help you kind of, you want to say, answer this question in as much detail as you like, I'm happy to do that. I don't know if everyone else is quite as in-depth on spectral power distribution and CCT and its go topics as maybe you are, but we can take this offline if you like.
Sure, yeah.
Any other questions?
Saeed has another question. He says, also, do I have to meet the Illuminaca and Luminance for my streetlight project? So do I have to? Not legally. And if we're looking at it from a legal standpoint, you do not have a requirement to meet the luminance or illuminance metrics by law. However, like I was saying before, there's protection in meeting standards, and it's something that I would personally pursue. Compliance to standards is, to me, it's peace of mind. Knowing that I'm meeting standards, knowing that if I ever get challenged on how this system performs, I've got a solid argument and a solid protection, if you will. Now, that doesn't mean I don't get sued someday if I happen to run a muni and somebody decides to run off the road and hit a pole. But what that does do is give you as much protection as possible in managing or mitigating legal liability. Other questions? He says, one more question. When should I use horizontal luminance or vertical luminance?
Your horizontal luminance is going to be for like your roadway type application. Your vertical luminance is going to be more like sidewalk. It's going to be so your vertical luminance is going to be for when you're trying to do facial recognition. So as two people are approaching each other, how quickly can they identify each other, friend or foe? Whereas with on the roadway, you're more looking at horizontal. And it's kind of a general rule of thumb is when you're looking at object recognition, facial recognition, you're looking more at the vertical. When you're looking more at, let's say foot candles over an area, like in roadway, you're looking more at horizontal luminance.
He says, thank you.
My pleasure. And there's my phone number. If you have more questions, please feel free to give me a call. Anyone else?
All right. If you want to talk a little bit about IES and if people can't make it, we do have an Instagram account now and a Facebook. We're either going to do a Facebook story or Instagram story or Facebook Live.
Okay.
So you guys can follow us on our new Instagram page. There's no content on there yet since we just launched the brand today. So feel free to follow us. The Instagram handle, we are sending out an email today, which should be in your inbox right now. And at the very bottom of that has our Facebook and Instagram link. The Instagram handle is Vega Light Control. And the Facebook is facebook.com/Vega Light Control Systems. And again, it's at the bottom of the email that you guys will get. We just sent out the brand email. So feel free to follow us, and we will post photos and some live feed of the show and our new product launch coming up later this month as well. So.
Excellent. And Katie, just to your point with regards to IES, we are going to be at the IES Street and Area Lighting Conference in Orlando, and we're very excited about that because we're going to be announcing some new products, and that we've always strived to achieve best in class performance in every application that we work in, and we've just set a new benchmark, and we're just really excited about it. So, anyways, I can't share the whole thing yet. Legal has not given me the green light from a patent standpoint, although that should be coming through here in the next few days. But I'm really excited about the product. I think it's going to be a game changer. And I hope if you guys get a chance to go to the IES Street and Area Lighting Conference that you'll come and visit us. We'll certainly make it worth your time just in sharing the new product.